Tangent line problem. So these notes right here should look familiar from today. Basically, we're really trying to find slope in the most complicated way, okay? So the good old days, rise over run, y2 minus y1 over x2 minus x1, delta y over delta x, right? Change in y over change in x, that's slope. And that's specifically always been the slope of a secant line, like the green line in the picture, the top line. If we want to find the slope at one point, though, the slope of a tangent line, what we want to do is make the difference between the two x's smaller and smaller and smaller. So we want delta x to be smaller and smaller and smaller. So if I apply a limit to delta y over delta x and take the limit as that delta x approaches 0, right, of delta y over delta x, the denominator gets smaller and smaller and smaller, and our secant line becomes a tangent line. The slope of the tangent line in calculus we refer to as the derivative of the function. Okay, so we have a formula that we need to generate to find this derivative. The word derivative is obviously less letters than it takes to say slope of a tangent line. So derivative is kind of better, right, than slope of a tangent line. But another way to define it, or a notation, I should say, for it, is to use a prime symbol. Okay? F prime of x. That's going to be our go-to. We're going to say f prime or y prime a lot of the times because you know how our equations, we usually write y equals instead of f of x. So if it's y equals, we say y prime. Y prime denotes the derivative of the function, okay? So f prime of x is the derivative of the function. I'm using f prime right now because I need to find a way to rewrite this delta y. Delta y needs to be changed. I can't call delta y y2 minus y1 anymore. Okay, you see showing up at the bottom there. I need another name for y2 minus y1. I want to write y2 minus y1 in terms of x. So I'm changing the graph that we had a second ago. First, I got rid of the orange and the purple line, but I'm going to change the blue curve to being called f of x. So this first point, the red one here, is no longer x1, y1, right? It's x comma f of x. If the x coordinate is x, then the y coordinate is f of x, right? Because you've learned years ago that y is equal to f of x. F of x is the same as y. It's just a more complicated way to say y. And so we're now going to rewrite y2 minus y1 in a more complicated way, and it's going to look really complicated and annoying. But it'll help us with this formula for the derivative, this formula that we're trying to come up with. Okay? So the first dot is x comma f of x. This is where it gets a little bit tricky. I don't want to name the second dot over here in terms of x2. What I want to do is I want to name it in terms of x. Notice I don't have x1 anymore. I got rid of the subscript. I'm just calling the first x coordinate x. So if I walk from 0, right, a distance of x units, and then from x I keep walking all the way over another distance of delta x units, right? How far have I gone when I've gotten to this green little line segment down here? Erase all my circles. How far away am I right here is I'm at x plus delta x. Right? Like if the x unit is, say, 3, and then my delta x is 5, I've walked a distance of 8 because I went 3 plus 5, x plus delta x. So that is going to be my new x coordinate on this point down here. Right? The x coordinate is x plus delta x. And that's pretty terrible, you know, to name an x coordinate as two terms. But that's just how we're going to have to do it for our formula. And what's even worse than the x coordinate is, what do we call the y coordinate? The y coordinate is the function's value at that x coordinate, right? So if the x coordinate is x plus delta x, the y coordinate is f of plus delta x. And there's my point right there. You might be thinking, what is your point, dude? There's my point. My point is x comma y, as it was in the good old days, but now it's x plus delta x, comma, f of x plus delta x. That used to be x2, comma, y2. Those were the better days, right? We've seen some better days. x2, y2. And x2, y2, if you go back up to the formula in the very top right corner here, right? There's my x2, y2. So I've got to replace x2, y2 with this new set of ordered, this new set of ordered pairs, right? Which is going to make my slope formula look a little bit ew, a little bit nasty. Let me move this up. I got make more space. Space. There never seems to be enough space. Space. So now I'm going to rewrite the slope formula using my new points. The red one, x comma f of x, and this new creepy, scary green one, x plus delta x, comma f of x plus delta x. So what is my slope? My slope is f of x plus delta x minus f of x. It's y2 minus y1 over x2 minus x1. And what's x2? x2 is x plus delta x minus x1. And what's the first x coordinate? That's x. So I'm using the exact same slope from middle school. It definitely got ramped up a little bit, you know? It's like, you haven't seen slope in a long time, like you went to different high schools, and then all of a sudden years later you see slope and you're like, ooh, slope, you've gotten ramped up, it's not scrawny little like 80-pound slope anymore, we got some big bulky slope, Um, so slope has put on a lot of muscle here. F of x plus delta x minus f of x all over x plus delta x minus x. So if I were to take this, I think I might pick a new color here because we're boarding on a lot of green. I thought I switched to purple. I'm going to simplify this formula a little bit. There's a little bit you can do, and that would be in the denominator. What is the denominator when you do x plus delta x minus x? Well, it's just delta x. So if you think about it, all we did was we found a really, really confusing way to write delta y. Delta y, right? Used to be just y2 minus y1, and that wasn't so bad. Now I'm calling it f of x plus delta x minus f of x. Because I'm coming up with a formula that's going to tell me how to find this derivative thing. Okay? I'm coming up with a formula in terms of the function. And the function is in terms of x. So I'm writing it as f of x plus delta x minus f of x all over delta x. And what did we learn about this same formula a minute ago when it was up on this screen? Oh my goodness. Up here, it was called derivative when I did what to it? When I made the denominator get smaller and smaller and smaller. When I made delta x go to 0. The limit as delta x approaches 0. What do we call this? We call this f prime of x. This is our formula for the derivative. This is the limit definition of derivative. I'm going to abbreviate that. The limit definition of a derivative. The good news is there's going to be other ways to find derivatives. We start out using this limit definition, okay? It's kind of like, you're a young kid and you help your dad with a project. And you don't get to jump straight to the circular saw. I remember my grandpa was painting a bedroom when I was a kid. This is my Papa Martin, whom I'm named after. And my grandmother, she gave me a bucket of water with a brush. And she was like, here. And I didn't want a freaking bucket of water. I wanted to paint. But you do kind of need to wash the walls off before you paint, So she was wanting me to like wash off the cobwebs and the dirt spots and all that, But I wanted to paint with a real paint. But you don't give like a 5-year-old kid a bucket of paint because it'll be everywhere. It'll be a mess, right? So we're building on this concept, and we now have a bigger tool, right? So we have this bigger tool of a limit definition. The good news is we're going to get to move past it. We get to move past the bucket of water and actually have paint someday. But for right now, this is the setup. Okay, so what in the heck does this mean? This formula. Notice the limit as delta x approaches 0. It's a formula that will help me find the derivative of some other function. Well, that's where you have to start. So question number 1. what's the function, right? So I have a formula in that purple box, and you see I rewrote the formula again here in red, and I'm going to keep rewriting it. It's kind of a lengthy formula. I'm going to keep writing it over and over and over again, but you can't do anything with this formula until you have a function. So my function in this case is f of x equals 7x plus 13. And so the question is, what is the derivative of 7x plus 13? What is the derivative of the function 7x plus 13? There's a way to get the derivative. And the only way I know right now is this limit definition. Unless you guys have been watching Khan Academy videos, or maybe you've already taken calculus once, or you have an older sibling, or you're just born super genius. You've studied this on your own. Right now, some of you are laughing about this limit definition because you already know the answer. It's literally like a blink of an eye, and I'm hopefully going to get to that by the end of this video, so we can see how to know some of this stuff faster. But I'm starting at the beginning because this is where we are. Notice I wrote f prime is the limit as delta x approaches 0 of fx plus delta x minus fx all over delta x. That you have to get that formula in your head. That's the first step of this class is learning that formula. Almost guarantee there is an AP exam question with that on it, especially if there's multiple choice questions. So this past year, there were no multiple choice questions, so it might not have necessarily been a thing on the test, actually. Okay, there's always a multiple choice question with this thing. And we're going to look at this throughout the year. This will become easier and easier and easier, but day one, I get it's confusing. So notice it's a f prime of x equals the limit as delta x approaches 0. There's a divided by, and there's a delta x in the denominator. That part's always the same. That part doesn't change. Even in the numerator, there's always a minus. Okay? What changes is the actual function, right? The function's going to change from problem to problem to problem because we have, infinity number of functions. What's the derivative of the square root of x? What's the derivative of tangent x? What's the derivative of, square root of tangent? Holy moly, that's a mess. Regardless of what the function is, the limit definition is this. And so you're going to write out limit delta x approaches 0 divided by delta x with a minus on top every time. This is like a template you can write out every time. Okay. What's the easiest part next? What's the next step? Next step, I say, is to go with f of x. F of x is right there. See, the function that you're given, it's a part of the limit definition. So after the minus sign, you're going to write 7x plus 13. But notice I didn't just write 7x plus 13. The minus sign has to be distributed to every term in your function. If your function is only one term, right, if it's a monomial, well, then you don't have to put parentheses. But usually there's more than one term, so you must use parentheses. This is where the most amount of mistakes happen with this formula is people forget to distribute this minus sign. Okay, so if you write 7x plus 13, without the parentheses, that's a boo-boo. That's bad because then you end up with a plus 13. You don't want that. This is the part that's the most confusing. F of x plus delta x. What in the heck does f of x plus delta x mean? Okay, hopefully you would know what this means. And maybe just to review, what if I were to ask you, what's f of 2? F of 2 would mean 7 times what? Times 2 plus 13. And what is 14 plus 13? I'm running out of space. 27, right? So pretend like x plus delta x is just a pretty little 2. Okay? This is like having a 2 right here, x plus delta x. I'm going to insert x plus delta x into my function, just like I put in a 2. Now, 2 was a monomial. So we're back to this issue with parentheses. So when I do 7 times 2 plus 13, I have to put the 2 in parentheses. 2. X plus delta x is a binomial, so I have to have it in parentheses. So that right there, boom, that is your setup. This is the part that's really unfair because not only do you have to write the problem, but then you have to solve it. So normally we would have done a lot of this in class. Before I even got into this limit definition formula, we would have practiced problems that look just like this. Okay, I would have started with just get rid of all this here. Like I would have given you guys in my pre-cal class a problem that looked like this. Like we would have just done this kind of problem over and over and over. And I wouldn't have mentioned tangent lines and slope or any of that crap. But I'm sort of at a place where I'm trying to speed everything up. Now, How do I solve this limit? Notice this is a quirky kind of limit because it has delta x's in it. Oops, I'm on the erase tool. And it has x's in it. So remember, x and delta x are not the same thing. X and delta x are not the same thing. They are different things. So what I can do is I can first plug in 0 for delta x. Let delta x be 0. And I would plug in 0 and get x plus 0 plus 13 minus 7 times x plus 13 in parentheses all over 0. Right? All I did was plug in 0 twice. And notice what happens in the numerator is you end up with 7x plus 13 minus 7x minus 13. And everything on top goes to 0. So if you could think back to like April and May right now, 0 over 0 means do more math, right? This is what we call the indeterminate form. And when you get indeterminate form, what that tells you is there is an answer. This is not the limit does not exist. 0 over 0 means there's an answer. You have to do more math to find it. And that will always happen with these limit definition of derivative problems. You'll always get 0 over 0. So we have to do more math. Now, what is the more math that I can do here? Red and blue make purple. I can distribute on top, right? What is 7x? 7x. What is 7 times delta x? That would be plus 7 delta x. What's a plus 13? Plus 13. Minus 7x, and then minus 13. This is some cool algebra, right? Algebra is happening. And you guys are like, wait, we're starting school already? What happens in the numerator now? The numerator does something very special. And this will happen every time. If you have a term in the numerator that doesn't have a delta x, so this problem is kind of all about delta x. The delta x terms, they're going to hang around, but every other term without a delta x should cancel out every time. Okay? Say that again. Every term without a delta x should go away. So the 7x right here, notice it also has a partner minus 7x. And 7x minus 7x cancel out. And then there's a positive 13. Notice 13, it doesn't have a delta x. It's just good old-fashioned 13. Minus 13 cancels out. So those big zeros in there disappear. And what's left is I have 7 delta x divided by delta x. And this is why what has to happen every time is the delta x's hang out while all the not delta x's go away. Because I'm going to plug 0 in for delta x. And remember, this formula has a delta x in its denominator. Every time there's a delta x in the denominator. And you can't plug 0 into the denominator. Ever, right? So what will happen every time is the delta x's cancel out. Every time the delta x's should cancel out. Okay? 7 delta x divided by delta x. Now the delta x's cancel out, right? Or they simplify to 1. And what are you left with is you're just left with the limit as delta x approaches 0. Maybe I should write this part. I'm running out of space. Space. What is the limit of a constant like 7 as delta x approaches 0? Notice 7 has nothing to do with delta x. Delta x can do whatever it wants, and 7 just stays 7. It's a constant. This is one of our rules from limits last semester, was that the limit of a constant is the constant. It doesn't change. Right? 7. The limit as delta x approaches 0 is 7. It's kind of like, you're a junior or senior in high school now. So like your 4th grade brother, like he can do whatever it wants. You're just going to do what you want. You're still 7, right? The little brother can be throwing a tantrum. You're like, okay, whatever, you're stupid. But 7, the limit is 7. So I made another example for you to try on your own. Okay, example 2. This video is already longer than I wanted it to be. I always tell myself I'm going to do these videos in 10 minutes. Sorry. F of x equals 3x plus 9. At this point, I want you to try to work this one out on your own. Okay, you see there's example number 1 there. You can you're going to have to basically marry these two expressions. You take the function f of x equals 3x plus 9, and you take the formula for the derivative, f prime of x, right? Red and blue make purple. And you want to write f prime of x equals, right? And what is the first thing you do? Well, like I said before, the limit stays the same, the divided by stays the same, the delta x is always in the denominator, and you have a minus in the numerator. So write out your template first, and then fill it in with the function. This is a different function than problem 1. So try to work this out, and then you can check your answer. So pause the video right now and work this out. Some of you guys already know the answer, but I want you to write it out because, this is math. It's fun. So I'm going to pause. You pause it. I'm going to jump to the answer now. Zoom. Pause it. You better pause it. Are you pausing? Okay, pause it because here comes the answer. If we ain't got time to pause it, Quirk, you've already taken too long. Look, the answer is 3. The limit as delta x approaches 0 of 3 times x plus delta x plus 9 minus the quantity 3x plus 9. Every term without a delta x will cancel on its own. 3x minus 3x, 9 minus 9 cancels out. And I'm left with 3 delta x in the numerator divided by delta x in the denominator. And the limit is 3 as delta x approaches 0. Cool. So example 1, example 2 are very similar. Obviously, we're not going to use lines every time, but I started with lines because they're the best ones. Remember, this whole derivative thing is about the slope of a tangent line. That's what it's about. That's the concept behind it. Is the slope of a tangent line. Slope, okay? If I have the function 3x plus 9, so I made a picture of it, right? There's a graph. And say I wanted to be a tangent line to the line. Let's pick yellow. The yellow pops, right? If I want to be a tangent line to the line, y equals 3x plus 9, what is the slope of the tangent line going to be if I put the tangent line next to the line? So like our definition of tangent that we talked about, in class was that, it's a line that touches the curve at one point. Well, that's not true at all. If your function is a line, how many points does the tangent line touch the line? The tangent line touches a line in infinite points, right? But it's still tangent to it. You could argue, well, it's not, it just is the line. So you're right, it's the line. So if I ask you in question 2, what's the slope of 3x plus 9? I would hope you would go, oh, well, the slope is 3, right? The slope is the m, and the x plus b, mx plus b. Oh, no, I had to freeze again. Don't freeze on me. Don't fall apart on me tonight. Oh, come on. Feels long enough. My computer is stuck. Boom. Google. Boom. 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 This is going to be a problem all year long. I can't do this. I'm going to have to buy something new. Look, it's me and Mary. There's our new picture, Mary. If my tablet's working, my laptop has got a problem. So let's go back to problem number 1. Y equals 7x plus 13. What's the slope of 7x plus 13? The slope is 7, right? So when you're asked what's the derivative, in this case, let's use y. Y prime is 7, right? If the function is y equals 7x plus 13, dang it, it did it again. It doesn't like it when I undo. It's like the computer can't handle it. Oh boy, I'm going to be in trouble. I just don't think I can handle it. Don't fall apart on me tonight. Bob Dylan song. The derivative of y is y prime. The derivative of 7x plus 13 is 7. Okay? It's about slope. So if I went to a whole nother example that dealt with slope, this one. I have 2 more problems and I want to be done. Y equals 5, or f of x equals 5. Okay, ooh, I hit undo again, that's bad. If I were to ask you, what's the slope of this line, y equals 5? What is the slope? Hey, it's working. Keep working, please. it's like exponential, you know. We went for like ever. This is a sign of the video saying, "Yo, bro, even I'm bored with you. Can you please shut up?" Um, the slope is 0. If you tried doing your whole formula for the derivative, you would get 0. How does the formula work here? Remember, the formula is the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. That's our limit definition of the derivative. For this problem, what is f of x? Right? That's the part that's easiest to start with. F of x is 5. The delta x is in the denominator. What is f of x plus delta x? If your function is 5, what's f of 2? F of 2 is 5. What's f of negative 1? F of negative 1 is still 5. What's f of u? It's still 5, right? What's f of x plus delta x? It's 5. So for this problem, it's even easier than the line because you don't have to distribute the slope and combine like terms. You just get 5 minus 5 is 0. And what is 0 divided by delta x? 0 divided by delta x is 0. So what's the limit as delta x approaches 0 of the number 0? Again, the limit of a constant is 0. So is it possible to do one of these problems and not have the question be the limit of a constant? Of course. So for our first couple of examples, these were linear equations. You see example 2 is a line, the blue line. Example 3 is a line. If I ask you what's the slope of the line, it's the slope of the line. If I ask you what's the derivative is the slope of the line. So when your function is a line, it's the same thing as asking derivative. Right? What is the derivative of a line? Slope of the line. What is the slope of the line? The slope of the line. But when you have a parabola, if I were to ask you, what is the slope of the parabola? Well, you could maybe say it doesn't have a slope, or you could say it has infinite number of slopes, right? The parabola is not a linear function. Let's pick my line tool. But like if I draw a tangent line back here, say at -2, the slope of that tangent line is definitely not the same as the slope at 1, right? The slope of the tangent line at 1 is not the same as the slope of the tangent line at 0. At 0, the slope of the tangent line, well, that was supposed to be 0. At 0, the slope of the tangent line should be 0, right? The tangent line at the vertex of the parabola is a horizontal line, right? At the vertex of the parabola, the slope is 0. That's what makes it a vertex. That'll be an important thing to work on later. Is how do you know when a graph has a vertex, or it has a minimum or maximum of any kind? How do you know when a graph has a bendy point in it? You check to see when the derivative is 0. You check to see when the slope is 0. So for a parabola, the slope varies. For a parabola, the slope is not always the same. For a parabola, the slope changes depending on which x you're using. Oh, that makes sense. Whereas when we had a line, if I asked you what's the derivative, it's just the slope of the line. So you don't have to do any of that calculus stuff, right? You just know it's the slope of a line. But for a parabola, it's going to take a little more work. So what's the more work? The more work is I do the limit, delta x approaches 0, divided by, I'm going to turn the line tool off, delta x in the denominator, in the numerator minus. That's your template. This is like a Mad Lib. So Spivak, I owe you some more Mad Libs, bro. They're in my desk at school, I guess, or on my desk. I don't know where they are. Second period pre-cal alum. Whoop whoop. Right. So f of x plus delta x minus f of x. I got to do the f of x plus delta x part, and I got to do the minus f of x part. What's the easier part? The easier part is the f of x part, right? What is f of x? F of x is x squared. Always easy to put that part in next. So you write your template, you put f of x in next. Then you have the f of x plus delta x part, which is the more complicated part. And so for this function, what is my function? It's x squared. It's something squared. So if I ask you to find f of 2, you would do 2 squared. If I ask you to find f of 7, you would do 7 squared. What's f of x plus delta x? It's x plus delta x, quantity squared. And how do you square a quantity? A binomial is a FOIL problem, right? So we're turning in, we have to FOIL now. And I've already taken too long, so I'm just going to FOIL it for you faster. It's in class, we'd go through this in more detail, I guess. But what's x times x? X squared. What's x times delta x? It's x delta x, but there's 2 of them, so you double the product of the 2 terms. Right? You square the first term, you multiply the 2 terms together and double it, and then you square the last term. And the last term squared, delta x squared, literally means delta x times delta x. So you do need to put in parentheses. If you don't use parentheses, then technically you're talking about the change of x squareds. Okay, so like delta x squared is different than delta x squared. What you have on the screen right there is delta x squared. And it technically does matter. Semantics, right? So there's your binomial squared part. And so now, looking at the terms in the numerator, how many terms are in the numerator? You see there's 1, 2, 3, 4 terms. 4. How many of them have a delta x? This is kind of different. 2 of them have a delta x, 2 of them don't. So what happens to the 2 terms that don't have delta x, right? X squared and x squared, they partner up, right? They take off, they leave the scene, right? They go to Vegas, get married, the Elvis Chapel of Love. Hey, baby, let's go to Vegas. So the x squareds are gone. They're not going to play anymore. They're out, right? They're at the movies already. But notice there's 2 terms left. There's 2 terms left in the numerator, a 2x delta x and a delta x quantity squared. And those 2 terms have one thing in common. What is a common factor that we have in those 2 terms is we have a delta x. And what can you do with a common factor? You sh it out. Everybody say it. Shh. One more time. What are we going to do with the delta x? Shh. Out the delta x. I didn't have to factor out the delta x on the last 3 examples because in the last 3 examples, it like kind of just canceled out, right? There were monomials on top, right? But what I have now is I factor out the delta x and I have a 2x plus delta x left over. And this is kind of funky because even though the delta x's cancel, so now is it safe to plug in 0? I can plug in 0. I don't get 0 over 0 anymore. The 0 over 0 cancels out. The delta x in the denominator should always cancel out. That's why we did more math. And I did a lot more math this time. You notice what's left over is the question, the limit as delta x approaches 0. Maybe I should rewrite it just this one time. Is 2x plus delta x. And what you are going to do is plug 0 in for what? You're going to plug 0 in for delta x. I'm taking the limit as delta x approaches 0. So this delta x is going to go to 0. And what's left over is a 2x. Because what is 2x plus 0? 2x plus 0 is 2x. So what you're telling me, Mr. Quirk, is the derivative f prime of x, the derivative of x squared is 2x. Is that what you're telling me? The derivative of x squared. If the function is x squared, then its derivative is 2x. And that is true every time. Okay? You look at this and you might think, well, can I just take the 2 from the exponent and put it out front? It's almost like, the 2 just fell down out front. Wouldn't that be cool if that's actually what we could do? But what does this freaking derivative tell me now? Because notice in example 4, the difference was this is not a line, right? The issue here with example 4 is it is a parabola. And what is the slope of the parabola? The slope of the parabola depends on x. The slope of the parabola depends on which x value you are sitting at. The slope of the parabola, okay, is 2x. So if I'm sitting at x equals 0, right, this orange line that's right here on the x-axis, right, at x equals 0, what is the derivative at 0? What is f prime of 0? That would mean 2 times 0. And what's 2 times 0? Well, that's 0. Obviously, it's 0, dude. Right? The slope is of a horizontal line. Let's jump over here to where x is 2. I didn't draw this tangent line in, but I'll put it in now. What is the slope of the tangent line when x is 2? If x is 2, what is f prime of 2? What is the derivative? It would be 2 times 2. And what's 2 times 2? It's 4. That's kind of quirky because 2 squared is also 4. So I know you're thinking, well, f of 2 is 4 and f prime of 2 is 4. That doesn't always happen. Go off the grid. 3 is way up here, right? What's the slope of the tangent line at 3? The slope of the tangent line at 3 is 2 times 3. And 2 times 3 is 6, right? So at 3, the slope of the tangent line is 6. At 2, the slope of the tangent line is 4. Negative 2, what's the slope of the tangent line? F prime of negative 2. It's negative 4 because 2 times negative 2, right? 2x. 2 times x. 2 times negative 2 is negative 4. And the slope of that orange line right there, go back to orange, make it fatter. Right? This orange line definitely looks like it has a negative slope, and it's pretty steep, like 4. So a lot of the times, our derivative is going to be a function. Our derivative is going to have an x in it. The derivative will be like a formula. It's almost like, and this is where the word derivative comes from. Like, I always think of derivatives before I became a teacher in math and all that jazz. It was about medicine. So like you have like a name brand drug, and then you have like its generic version, which is usually cheaper. Like so you have penicillin, you have amoxicillin. So they're somehow connected. I'm not into pharmacy, and I don't really know the details. And if a pharmacist was here, he'd probably laugh at me. But we call those derivatives, right? It's a derivative of the name brand, of the main brand, right? So it's kind of like you guys are all derivatives of your parents. Get out of here, little derivatives. Give my nerves. So little derivatives. Shut up, you little derivatives. You don't know what you're talking about. I'm a grown man. I know what I'm doing. You know what I'm saying? That kind of thing. So your offspring, right, are like your derivatives. So the derivative of f is f prime, and they are connected through this concept of slope. So imagine when you have like a sine function, right, or a cosine function, the tangent lines, right, would be the derivatives, right? How do I get the slope of these tangent lines? I need to know the derivative of sine. But obviously for a sine function, the derivative is going to change, right? The derivative is going to be something different every time. Take like an exponential function. Oh, and it froze. That means it's time to quit. So I'm going to make up a couple problems for you to try on your own. Hopefully you got through this video. I'll let you have a couple days to watch it. How's that sound? But how long is it? I really don't even want to know. How do I get back to where I was? I guess I just have to hit stop sharing. Oh well. Hey, you guys have a beautiful day. I'll see you soon. See you on Thursday. Bye.